In this video, we'll walk you through building a spatial environment in the PanSpace. We'll add a plan image as a reference, define a scale, and add loudspeakers. When building a show file with a SoundHub, it's vital that the processor has an accurate representation of our venue, our loudspeakers, and the spatial relationship between them. This forms the basis of our show file. Let's start with a blank show file and walk through building a basic venue. If you haven't already, now's a good time to create a new show file by clicking on the File menu and selecting New Show. Store your show file in an appropriate place on your computer. A copy of the show file will also be stored on any connected SoundHub. The cue list is currently empty, and before we can add any data to the show file, we'll need to create our first cue. To do this, click the New Cue button. This dialog will appear. We'll call our cue Base State using this field, and click OK to add the cue to the cue stack. From our mixer window, we can now use the toolbar to navigate to the PanSpace. The PanSpace itself is divided into 4 layers, and the current layer can be selected from this list in the left-hand side contextual menu. We'll start in the venue layer, so let's select that layer now. We always advise creating or obtaining a plan view of your venue before creating your show. You can import most types of image file into the PanSpace as a background by using the Load Image button that appears when you are viewing a venue layer. Let's add our background image now. The image can have its opacity adjusted or its colours inverted with these controls in the left-hand pane. Once we've imported a background image, we can tell TiMax the scale of our space using the origin and reference points that appear within the venue layer. It's important to note that the origin should match the origin or 00 coordinates of any tracking system you may be using. If you aren't utilising a tracking system, then we recommend placing your origin at a point that's easy to take measurements from, such as downstage centre. Your reference point can be any given position in physical space that you can take a measurement from. This position needs to be marked on your background image. In this example, we'll use the central rear seat in the stalls. When we have this measurement, we simply place the origin and reference points at their corresponding positions in space and input the distance between them in the field on the left-hand side. It's crucial that we're as accurate as possible with this measurement, as all the calculations related to distance that TiMax performs will be based on this. We can adjust the units used as well as the grid size and colour using these menu items in the bottom of the left-hand pane. With our background image placed, and TiMax aware of the scale of our venue, it's time to start placing loudspeakers. To do this, let's navigate to the speaker layer using the Layer Selection tool. Now we're viewing the speaker layer, we're presented with a list of speaker types. As this is a new file, the list is currently only populated with the default type, so let's add some more. It's important to note here that the reference to the type of loudspeaker doesn't refer to its make or model, but rather to its function, such as front fill, main system, delay, or surround. To begin with, we'll start by creating a new type. And for this example, this will be our main front-of-house system. Upon hitting New Type in our left-hand pane, we'll be presented with this pop-up. First, let's name our new speaker type Main. We can select the icon that will represent our loudspeaker, the colour of its dispersion pattern, and most importantly, how audio objects will interact with this type of loudspeaker via the image definition calculation settings. These calculation settings control both the level shading and the fixed delay that audio objects will exhibit when interacting with these loudspeakers. The distance parameter determines how quickly level will drop off as an audio object moves away from the loudspeaker. This defaults to 3 dB, which results in a 3 dB drop-off per doubling of distance, or half that of the inverse square law. A value of 2 to 3 dB is adequate for most productions, but depending on the use case, this could be set to 0 or to a much steeper drop-off. The angle parameter determines how quickly level shading will occur as an object moves off the centre axis of the loudspeaker. This is vital to consider for loudspeakers such as front fills or for surrounds to ensure that the audience localise to our performers and not the loudspeakers that may be closest to them. We recommend that you start with 0.2 dB per degree of shading and experiment from there. 0.2 dB per degree means that a 10-degree move from the centre axis will result in 2 dB of shading. Sometimes you may want to keep this at 0, such as when using a monoblock of subwoofers in a 360-degree experience. Mix minus is a feature that can be a huge time saver when using live microphones. This parameter will, if set to 1, attenuate the loudspeaker 1 dB for every calculated millisecond of negative delay. We can use this to turn the speaker down automatically when a performer steps in front of it, preventing feedback. Finally, overdelay is simply a further fixed delay amount that can be added at the end of the calculation. This parameter can help push loudspeakers back in our spatial mix, causing audience members to better localize to the action happening on stage. Now we're happy with our new loudspeaker type, let's click OK to add it to the file. After creating our loudspeaker type, we're then free to start placing them within the PanSpace. Simply select the loudspeaker type you wish to place, in this case our main, and double-click on the PanSpace background. This will prompt us to map an output channel to this location. You'll see in the left-hand pane that this newly placed loudspeaker has an XY location based off our origin and reference set in the last step, and a default Z-axis height of 0. Be sure to make note of the Z-axis height of your loudspeakers and populate this field as needed. After placing your loudspeaker, we can utilise the reference point handle to set the correct angle of this loudspeaker. Note that this reference point also has a Z-axis, shown in the left-hand pane. After you've repeated these steps for all your loudspeaker types, we'll be ready to move to the next PanSpace layer, and our next video, image definitions.